Hey everybody, this is Larry. Hit the like button, hit the subscribe button. Let me know how you did on this problem. I'm gonna solve it live right about now. Cool. 146 LRU cache. Design and implement a data structure for the least recently used cache. It should support the following operations: get input, get gets the value of the key if it exists in the cache. Otherwise, return -1. Put sets or insert the value if the key is not already in the cache. When the cache reaches its capacity, it should validate the least recently used item before inserting a new item. The cache is initialized with a positive capacity. Oh, this capacity, okay. I don't know why they put a bold on the positive and not on the capacity with that being a keyword. Can you do both operations in O1? Okay, cool. So yeah, so this is a relatively standard problem. I've gotten it a few times actually, so I'll do it for you. But the idea is use like a linked list type thing, which I'm going to do. Let's set up a node class. Yeah. I guess a node just needs to contain the value, right? And then also set up the next is none, and then that's pretty much all I need, right? I could do a little bit better. I could do also this previous, just for just so that we can remove stuff a little easier to write. But yeah, so then I would add capacity. Oh, I guess after capacity we have the UX stuff. So key, otherwise we put in the hash table, so I just put in a hash. And when we do a get, they don't actually tell you this, do they? Okay, the problem, I mean, sorry, I was just looking it up, like the condition of what's considered used in this LRU case, because some variation is like it's considered used if you do a get or a put rather, and some other cases they only consider it as used if you only put a put or something like that. So there's some variation. That's why I'm looking it up. But I guess we'll just do that. But yeah, on a get, we want to eventually return the hash of the key or -1. So let's just do that get. What's it, -1? And it's self.hash. But before that, well, if key is in hash or self.hash, then we want to move it to the front or the back. Also, yeah. So, I mean, I guess it doesn't matter because we're using a double pointer, but we put it in the, yeah, I guess we need both ends. Essentially, I just need to write a linked list function to it, or like a linked list class. But I'm gonna, yeah, if key is in hash, then we also want a node hash or node lookup. Maybe that's a better name. Yeah, then the node is going to have that node lookup of key. In this case, we already assume that self.hash and self.lookup is going to be the same. Though I guess we could have done it like, I don't know. We could put in the same thing in an entry type thing. All right, let's do that. Let's write more code. Why not? Key. Now this is a little confusing because the LRU itself doesn't make sense. Okay, cool. And then now we want to move it to the front. I always forget if there's a linked list class in Python, like there is in like Java. Maybe I should do it in Java. Yeah, okay, maybe not. Yeah. Hey, what's up, Dunkin' Donut? How you doing? Okay. Well, let's just say beginning of front and then end is equal to none. I guess in theory I should. Okay, fine. I just make a linked list class. I think there's also like a cleaner way to do with Serenos, but I need to get better about that. Okay. And you only really need two functions, which is append, I guess, a node, self dot, and if self dot front is none, then self dot front is equal to node, self dot n is equal to node, and then just return. Otherwise, then self dot n dot next is equal to node, node dot previous is equal to self dot n, and then self dot n is equal to node. And then you have the other one, which is was it move to n, say? And then in this case, this assumes that it is already in the tree. Maybe I guess I could. Maybe I could put this one. Okay, but okay. If self.front is none, then again we just do this thing. Though I guess it should already be in the tree, so or in the linked list. So maybe this doesn't come up. Shouldn't there be an else in line 24? Well, maybe my. Oh yeah, I mean I'm not done with this yet. Sorry. Work in progress. I'm just writing the link. I jumped a little bit back to my linked list. How are you doing, Frame Die? Ooh, have your interview tomorrow. Good luck, Dunkin' Donut. Let me know if y'all can help. Yeah, you're not wrong, Frame Die. It's just that I wanted to finish this and then I'll fill this out afterwards. Sometimes I jump around my head, so it was a little hard to follow. But yeah, if node is self.front, then self. Oops. How do I want to do this? If well, let's delete this node. So node dot if node dot previous is not none, then node dot. I guess this doesn't really not. Oh wait, what I want to do is this is equal to none, and then node dot prev is equal to none, and then if node.next is not none, next.prev is equal to none, and then node.next is equal to none. And then now it is deleted, and then now we can just append. No, yeah, it's a little odd, maybe. But because that would make writing this really easy. Just try to think for a second just to see if this is right. Maybe it should be okay. We'll test it. Okay, back to here. If key is in hash, then oh yeah, you are. Well, if key is not in hash, then just return -1. Then this kind of mixed in then user. Maybe that's what you're talking about. And then because I kind of have this here, but it's a little bit weird. You are right. And then linked list, move to n of node. Is that it? I guess that's it, really. Oh wait, that doesn't make sense. I also need to, oh no, because I want to remove from the front. Okay, like a deck, except for with all of one movements. Okay, and then now put, okay. How do I put? Well, if key is in the hash, then we actually want it, well, we can just update the hash and then also just move it to the end. And that's pretty much it, I think. Otherwise, then this is a new element. So we want to solve that linked list, append a new node of just a value, I suppose. Oh, actually, this is the key. The value is the key. Yeah, okay. I think I want to put this here instead, the capacity, so that I don't, so that the cache don't worry about. Yeah, maybe that's okay. Where is it? And then in this case, that means I have to keep track. Okay, well. I think this should all. I want to do something like this, but then this makes this a little bit weird. I guess I could just do something like this, which is technically true because I removed it. And then now, if self.current count is greater than self.capacity, or then we want to just do self.front is equal to self.front.next. And then now self.front.prev is equal to none. If self.new front is not none. And then this will allow us to do this. Maybe even do a while loop just in case. Shouldn't happen, but okay. Let's put return. I guess it just doesn't return anything. Okay, oh, none. Okay. Oh, but then I have to direct the. That is to, because I removed it from here. Yeah, okay, maybe I messed up on the capacity actually on the actual coding, because maybe this should not be on the linked list, or at least, uh, hmm. Well, I guess I could return, this is a little bit of a hack, but we can return, uh, vector is equal to self dot front dot, well, oh, whoops, just a, okay. I'm not a fan of this design, and I want to spend time on it. I'll probably rewrite some parts of this, but for now, I'm going to just try to get it working. And technically, it's TDD, given that we have some sample cases. So that's a good place to start. That's my story. I'm sticking to it. So we do this, and then for each erected, we want to remove it from both. We get the key, unless I'm doing something silly. Yep. Okay. And also the what's it called? Node lookup. All right. Let's give it a try. Yeah. Yeah. Not a fan of it, but none is not. Oh, because of this. Uh-oh. Hash does not have one. Oh, I never actually put the stuff in here. um, in general. That shouldn't work the same one though, but I just never put anything in the hash table. Okay. Oh, and I also never put anything in there either. Okay, I need to actually, a little bit sloppy here on my end. I apologize for that. Well, it's close. So I don't erect something correctly, I think. Okay. Erect the 2, therefore 2 is gone. I'm just thinking about how I want to go about debugging it. Let's print out what we get erected, I suppose. And it doesn't erect anything at all. Oh, this doesn't set it up correctly. And there's some duplication of code, so let's just put this up here. Oh, okay, still the wrong answer, but hopefully less wrong. Okay, you mixed the wrong number. I just put this moving to n. Moving 1 to the end, I guess that's actually what I expect. So why is it removing 1 from the front? Dun, dun, dun. Okay. So the first append, and then the second append just returns an empty array, because the first one's here, and then here it returns the correct answer, I think, 1, and then it tries to move 1 to the end when inserting the 3, I think. Oh no, I mean, it just moves the 1 to the end. This should erect the 2, but it doesn't. It erects the 1 instead. Okay, I mean, so at least we know why that is, or how that is. So there's something here. Oh, this is incomplete because we don't deal with the front and the back. Ugh, this is so annoying. Hey, what's up, Dowso? How you doing? Or do you so? Learning Ruby through tutorial and class did go? Yeah, I mean, I would say so. There's Ruby in here, and you have to sort it by difficulty a little bit, and there are a couple of lists on that. But the easier problems are definitely easy enough for you to, get your fingers warmed up or get it wet or whatever the analogy is. Not good at it, that part clearly. but yeah, okay, I see why. Because this removes the node, but not from the front. The front is still this node because I don't update the pointers. Okay. I thought about this, but I forgot. Front, and self.foot. Where did I move the front? Oh, I guess I do it here. Self.front.next. If node is equal to self.end, then self.end is equal to self.end.previous, I guess. And now self.front.previous is none. And then now the new self.end.next is none. Okay. Yeah, that's the thing that I need to try. Okay. I hate you. Yeah, that's the thing that's the pattern that I need to learn, MWAX. You are right. I was actually talking about it a little bit earlier on the stream, but I mean, I just never did it that way, to be honest. But there's something that maybe I could be a little bit better about. It's not none, of course. But you, because there's a lot of just checking to see if they're nuns. Yeah, okay. Huh. That means there's something weird, because the reason why I don't have a check is because if the front or the end is none, then the front is also none. But clearly something's a little bit out of whack in the way that I've been doing it. Well, yeah, I think I just never learned that way. But yeah, maybe it's worth doing it one day, for sure. But yeah, UX none, UX still UX to 1, so that's not great. That means there's something still messed up with here. Yeah, this is really not supposed to be a hard problem, but but sometimes this happens. Print that out again. Yeah. I'm almost done. I just need to figure out why is this erecting the one? Because font is still font is none, but that's wrong too, right? Oh, I see. Because I do this stuff first. That if self.font is pointing to this node, then this stuff would already be none before. Okay. Okay. But yeah, that is poo. Oh, oops, how did that happen? Copy and paste over. But I mostly got this, right? It's just that I have that one error. Yeah. Oh no, and then there's another one because probably some other edge case. The LC solution basically just copies order dictionary. I guess so. I mean, but that's like the log n or whatever one, right? So, given this one, you put in a bunch of stuff. 432. What is the capacity? 3. You get the 1. It's not there. You put in the 5. Get the 1 again. Why is that -1 though? I know these are gets. So that's still -1 for 1, but 2. Oh, that's definitely wrong. Hey, what's up, Don't Drink and Derive? How you doing? Where's my thingy? Okay. Yeah. So we move 4, we move 3, we move 2 to the end. So now it should be 4, 3, 2. 1 doesn't exist, put 5. So 4, 3, 2, 5. No, it should be 2, 3, 5. Where do I erect? That's what I mean to put. Yeah, there's still something a little bit off because when you move 2 to the end, obviously the next erection shouldn't be 2. This one's right though, at least. Better than nothing. I need a print list. I was gonna write something like that, but then I just was hoping I wouldn't need it. Oh, don't actually call it, so that's not helpful. Hey, what's up, Now2? How you doing? Once again, I breezed through the harder problems and kind of maybe a little bit too cocky and struggling a little bit of these ones. But yeah, moving 2 to the end. And why doesn't the print do anything? I think it's just, well, I mean, it's obvious that some part of these is a little bit weird. He's done some. Well, I think this may get changed if they're pointing at this. No, that should be okay. Well, there is some like weirdness. Hey, have a good night, nitrogen ion 2. And 2, thanks for the follow, 2. Huh. I'm just working on some Leetcode, a very basic problem, LRU, but apparently I am having trouble with linked lists in general. I don't know, I feel like I have a good grasp, but maybe not today. Moving forward to the end. Why is this whole linked list stuff really weird? Let's just. Brain is cool, so squishy. Yeah. 1, 1, 2, 1, 2, 3, 2, 3, 4. Moving 4 to the end. What's my moving? Oh, and then it prints, which is fair. But then now let's print it after the move. Okay, 2, 3. 1, 2, 3, 2, 3, 4. Moving 4 to the end, so it's still true. Moving 3 to the end, and then now just 2. Huh. Because it is, because the 3, well, none of this is true. 3 is just in the middle. And then no, that previous is not on, so. So the 3, 2 to 4. Oh, this is, why did I do this like this? Now, what we want is next node on next. I'm going to skip the node, not just, okay, that's just a silly mistake. And then now we can do something like node.prove, because we want that to happen anyway. All right, well, now we got it working again. Let's see. Let me remove the print statements real quick if I could find them. Yeah, how did I end up spending on this one? Wow, half an hour. Why does it still print stuff? How come this didn't get matched on my search? Okay. Come on, big money. Okay, cool. All right. Well, I was going to make some comment about linked list, being able to visualize it. I mean, most my issue is just that I don't know how to implement a double linked list, or at least like it's been a while. So I think definitely, if you were me and I am me, because that's how me being me works. I need some more practice with linked lists. I just had a little bit of I don't know. I just didn't want to visual. I it's one of those things where like if you've done it like hundreds of times, sometimes you just don't think about it, but then you I don't know, have a silliness because even though because you're a little bit rusty, and that's kind of how I feel like I was doing because I just a lot of silliness. I would say definitely. I also second what Ambrax is saying, which is to look up cell node pointers. I'll probably practice that next. But I've seen someone using it before, but I haven't done it myself because I don't know. Back in the day, that's just not how people taught me, but I was taught. But you know, to grow, you always have to learn new things and incorporate new things into kind of how you do things, and you know, so I'll definitely kind of think about it and kind of read up on it. But overall, LRU cache, yeah, you just the basic idea is just using a linked list so that you could marriage a linked list and a hash table in a way such that everything is these like is all one kind of and that's pretty much it, because if using a linked list and if you could get the node in all of one time, you could keep a sorted list in all of one time. So yeah, and maybe I should have used it in Sumo Life. Yeah, and maybe that's what I need to do for use order tick. Maybe I should have used order tick then. I mean, I actually don't use order tick enough. Order dictionary. Um, hmm, but yeah, I have to read up the properties. I just don't know that much about it. But yeah, overall, I mean, like thankfully, when I was doing interviews, I definitely did that quite a bit better on interviews. Uh, but because I've definitely gotten this on interviews, even if we don't have to implement everything. I think I did it on a whiteboard, so that was a little bit hand wavy. But yeah, still get familiar with LRU cache just because it is definitely a problem that I've seen asked.